Greetings, the Astro 30 here, and today I received this Uni-T true RMS digital multimeter in the post. Paid about $49.95, I think it was, something around there, about 50 bucks, from a place in Sydney, New South Wales. So let's just see if we can open the box. This model number is a UT139C. I'm not sure what the difference between the different 139s are, but so open the package, and if I can get it out of the box. It's tough. I think that might be in the way. Let's try that again. There we go. Right, so we have a operating manual. It looks like it runs on 2 AA batteries, which is nice. I mean, older multimeters used to run on a 9-volt battery, but that's okay. Got the probes. That looks like a temperature probe, which is awesome. Yeah, I needed a multimeter that can measure temperature, and well, this is going to be perfect. So take that out. I'll remove the plastic crap on top. Now, do I have to take it apart to get to the battery holder? Well, it looks very much like I have to. It doesn't seem to move. That's just a stand. I don't even think that comes off, does it? It'd be very awkward for it to come off. Okay, so let me just have a quick look at the instruction manual to see how we install the batteries. That's in Chinese. I mean, it'd be alright if I could read Chinese, but it just looks like I have to remove one screw from the center of that stand to get access to the battery holder. That's all I really wanted to know, so I'll just grab a screwdriver and take out this screw, like so. It's a machine screw too, it's not a self-tapper or anything. It's a machine thread screw. That's kind of nice. Should pop off like that, which it does. Now I need to get my batteries. Don't know how good these are or how long they've been in here. You got access to a big fuse down here too for the current setting, which I believe is up to 10 amp. Doesn't actually, oh no, 60 amp. Wow. Okay, so positive goes around that way, but how do the two batteries join together? There's no metal thing here for the that's weird. Oh, I see. It's on the inside of the cover where you put the batteries, so they sit on the inside of the cover like this. Once I get the other battery out of its piece of plastic, and negative goes that way on that one. Okay, and then these just line up with these pins, but you've got to hook it in the front here, well, bottom, into its groove first before trying to push it down like that. And then we put the screw back in, and that should be ready to go once it's tight. Okay, so let's it's on off at the moment. Let's turn it on to something, say, I don't know, ohms, and we have a digital display saying open load. So that's also got an indication of a little buzzer, a little speaker, noise maker, symbol, whatever you want to call that. So that would be for the continuity check as well as normal ohms. What I'll do is I'll connect up the probes, which have very thin tips on it, so I suppose you can't come into contact accidentally with high voltage by accident. I suppose that's gone are the days of the old multimeters with long ass probes on them, like this old one over here with a probe that sticks out about, 15 millimeters, 20 millimeters. So the black one goes in COM. Helps to take the little rubber stopper out the end of the probe. There we go. And the red one too. I don't think those really are needed to be kept. You can if you want. And for volts, ohms, hertz, you can even measure frequency. Nice. And degrees Celsius, you plug it in this pin. So if I touch the two leads together, that was hold. It should beep, but it is giving me 0 ohms, but it's not giving me, it's saying kilo ohms, mega ohms, open load. Come on. 0.1 ohm, it's auto range. I've always wanted an auto range, but it doesn't beep. I would have thought it would have given me a continuity noise beep. Over here is a blue select button, which is /V/F/C. I think the F is for frequency, the C for maybe degrees Celsius, and V for voltage. But if you turn it, push it on a few times, you'll see there's a diode symbol over here now, so you can actually test diodes with the multimeter probes. Now if I press it again, it's just normal, still in auto range. If I press it again, not much is happening. Press it one more time and then we get a little symbol up here, so it makes a noise when you do that. So I guess that if you want to do normal resistance measurements in auto ranging, you press select so it doesn't go beep. But in normal continuity test, it's just doing that. So, and that's a diode test. There's auto range with an F on it, and auto range with kilo ohm on it. So, yeah, okay, that's fine. And you can always press this button over here to hold that measurement, so that you don't have to sit there with your probes connected to something all the time, and you can just press hold once you've got the figure and then view it later. And to get rid of it, we just press it, that button again, and it goes. There's a range switch, so that turns auto ranging on and off by the looks of things. You can go kilo ohm, mega ohm, ohm. Yeah, so that selects between the different measurement modes. In the resistance, same as going, like 200, 2000, 200k, 20k, 200k, etc. It's the same sort of idea. So it's no longer an auto ranging, but if you want auto ranging on, we would press the select button until auto range is displayed on the bottom. Okay, so let's go through some of the functions of this knob. So from the off position, we've got normal voltage, VFC. That's both DC and AC by the looks of things there. We've got millivolt amps and hertz as well, both AC and DC. the resistance, diode and capacitance check. So the C would stand for capacitance, obviously. I messed that up in the previous description. That's fine. Then we've got degrees C or Fahrenheit, hertz, microamps, but you'd have to change the red probe to the MA microamp socket, the same as if you're on milliamps over here. And there's also an amp socket for amps over here, but that's also hertz and hertz. NCV, and that I'm not 100% sure. I think that is like supposed to be a picture of a clamp, where you use a high voltage probe clamp, you clamp around your wire to measure the current, and it can do up to 60 amps. NCV should be that when you bring the multimeter into contact with a line such as an extension cord or something, it's showing you that there's a voltage there on that wire. So for example, it's telling me that power board is live. You never have to test to see if the wire is live, such as in your AC mains wiring in your house, or a light socket or power point, whatever, to see if there's voltage on the line. You can just hold it up to the socket and it will tell you whether or not there is power on that particular socket. That means you haven't isolated the circuit yet. Then that gives you the no go ahead to do any work on that circuit until you isolate it. So that's what that's for. Now what I want to check out is the temperature. So for that I need to unplug the normal probes, go over to degrees C, open this temperature probe bag, because this is proving challenging and making me look like a fool, but I can't get a simple object out of a simple bag. So I've had enough of this messing around, so I'll cut the end of the bag off and pull it out the reverse way. There we go. Now I'm going to take the twist tie off. It's not really even a twist tie. So this little pin is what you touch against something, and it shouldn't really matter which way around this goes. Oh yes, it does. It's actually marked. It says on here COM, and then you connect it to the temp or plus plug on the multimeter. So that would go across these two. And now currently it's picking up 15 degrees Celsius from somewhere. It's probably ambient temperature. If I touch the end of the probe, we can see that the temperature is starting to increase on the display as it's measuring the temperature of my finger. This is what you call a direct contact probe type temperature measuring device, and I doubt it's going to get to 36 on just my fingertip. And it's getting close to 30 degrees, but how accurate this is really, well, you know, really neither here nor there. Oh, my tongue is saying, sorry, even my tongue is saying it's 28 degrees Celsius. But if I wanted to measure the temperature of a heat sink, for instance, it'll give me a vague idea of how hot the device is getting. So for now, I'm not going to mess around with that too much because I haven't really got anything temperature wise to measure. I could measure the soldering iron, the Heiko one that I've got, just to see what its actual tip temperature is really, but ow, that hurt. I just pricked myself with the twist tie. Okay, so moving on, I'm going to go back to, maybe I'll test capacitance. And I assume you put them in the same holes. So yesterday in the post I received 6 brand new 10,000 microfarad 50 volt capacitors. These are not new. These are used as well. So I'm now having a fight with the seller on eBay to get my money back. So I need to go over to capacitance, which is on that scale. So I think I have to change the range here. Ohms, kiloohms, megaohms, hertz, percentage. That's voltage. That's Fahrenheit. Yeah, okay. Oh, that's capacitance. That's nanofarad. So if I put this multimeter probes on this capacitor, well, I don't know if it can measure a capacitor this high. Yeah, by the looks of it, not really. So that capacitor is way too big. So let's see, how about a 1 microfarad 16 volt jobby? Or is that 50 volt? What jobby? I think it's a 50 volt. I can't see, the writing's too small. I believe it's 50 volt. Anyhow, there's the positive there. That's the negative there. That's going all over the place because the probe's not making good contact with it. It's saying it's 1.236 microfarad. So, okay, that's well within the range. There could be about a 3%, plus minus error there too. So that's 1 microfarad. Let's try 2.2. Because these are Chinese capacitors too, so the tolerances could be way out anyway. I'm not sure if it really matters if you put the positive probe on the positive or the negative, but I'm putting it in the correct polarity, so we are 2.301, no, 2.2, alright, so say 2.3 microfarad. That's pretty close. Okay, so let's go up to 470 microfarad, and I am actually going to try reverse polarity and see if it still measures it. It shouldn't hurt the capacitor because it should be using a pulse width modulating oscillator to do the capacitance testing, not a voltage. And we have 456.8 microfarad. Okay, that's fine for electrolytics. What about some of these guys? This is a .22 microfarad, so a 220 nanofarad. So we measured that on the meter and see what we get. Oh, well, it's saying straight away that it's 234 nanofarad. It's kind of out, but okay, let's go for a different value. I'm not sure what value this is offhand. I can't remember if I can get one out of the box. We have a point, I don't think it goes up to 1 microfarad. We have a 0.47. Really? I thought they went up to 0.68, but anyway, 0.47, so 470 nanofarad. Yep, 480.4 nanofarad. So I know the capacitance tester is working. Let's try this capacitor here. This is a 0.033, so a 33 nanofarad. And that's measuring at 34 nanofarads. So I know that those are working. Let's start with a 330 picofarad, which I don't know what the resolution of this meter is, but we'll find out. Well, it's having an issue. It is coming down, but it's going up again. It is having an issue measuring picofarads below, well, obviously below a nanofarad here. So, I'm not sure. 683, that should be a 0.068 nanofarad. Sorry, microfarad, so that should be a 68 nanofarad. Well, it's saying 55, so it's nowhere near 68. So this is going to be a 6.8 nanofarad because it's a 682. So that's a 0.0068 microfarad. And that's more about 9.8. So that's well out of tolerance. It's now saying it's 10 nanofarad. But then again, these little ceramic disc capacitors, measuring them on a meter like this, there may be some form of error there. So those are all the functions I'm going to test and all I'm really interested in. I'm assuming amps and milliamps and microamps work. I don't really need to test those out per se. If it doesn't work, there's something wrong. But yeah, what do I think of the UT139C Uni-T auto ranging, manual ranging multimeter? I think it's quite good value for the money. It's, as I say, only 50 bucks. I got this in Australia. Even though my only gripe is the instruction booklet or user manual is in Chinese only. That's not very helpful to the rest of the world, just saying. And it is a true RMS meter, as they purport in the advert, but RMS would only come into account when you're measuring AC and, well, some DC voltages and DC current and AC current. Most multimeters average the voltage and current when measuring AC to display a voltage on the display. True RMS meters go a little bit further in the way they treat the measurement, and that's an engineering type side of things which we won't go into. Yeah, so I like it. I like the NCV function that you can hold it up to a source of AC power, mains AC power, and it tells you that the circuit is live. That's wonderful. And most multimeters these days that you buy have that feature on it, but I've never had a multimeter with one on it, just saying. But yeah, it does continuity mode, diode test mode, so I can test transistors. It doesn't have HFE mode on this meter like a lot of the old cheaper multimeters had. You know, where you have this little socket here where you can plug a transistor in to test to see if it works. This is like, a $5 multimeter. This is a $50 multimeter. There's like $100 and $150 to up to $600 multimeters where you don't need that function, because if you're going to buy a multimeter that's worth $600, why would you not know how a transistor works and how to actually measure it with just 2 probes rather than sticking the thing in a socket? Just saying. Anyway, I think it's great value for the money. I'm happy with the product. It runs on 3 volts, so standard AA batteries. How long they're going to last, I don't know. There is a symbol up the top here in the display which looks like a clock. That might be the battery indicator. I'm referring to this little icon up here. It looks like an arrow pointing that way. I think that might be the battery indicator. Let me just turn it off. Again, the manual is in Chinese, so any description of functions in there is not going to be very helpful to me unless I can read Chinese. So, this is going to be used in upcoming videos that I'm going to be doing because, well, why? Because I often film testing from on the floor level, And it's very handy, the fact that it stands up. Because if you remember from previous videos that I've had to always prop the multimeter up against something and it'll always either fall over, or I'm in the middle of doing the shot and I still have to use it because it's the only piece of footage I've got and the multimeter falls over. So that will eliminate that, and it's got a large enough display on it where the camera should be able to see it properly. So this is going to be a great piece of test kit. What I'm going to do with this to keep it from being lost is I might keep the little plastic tray. I don't need the box that it came in, but I'll keep the plastic tray that the meter came in, and I'll just pop it in there like that when I'm not using it. That way I don't lose the probe. And yeah. Anyway, I'm going to end this video here. I think I've talked on enough about crap. But yeah, I'll put a link in the description to where I found it. If you want to buy one, I'm sure if you're in another country you can find one. Just Google Uni-T, UT139A, B or C. There's like 3 different versions. I've got the version C. I'm not sure what the difference in between the versions is. Maybe someone can enlighten me in the comments below. Maybe start a discussion down there. But yeah, that's my little review of this relatively cheap multimeter. $50 is not that expensive. With decent heavy duty probes on it. So yeah, anyway, thank you for watching, and I'll see you in the next one.